How much does it cost to 3D print parts made of metal? In this video, we break down the basic cost components for metal 3D printing parts. Hello and welcome at Empower. Today's video is all about cost. So let's talk about how much does metal 3D printing cost. Metal printing is considered to be an expensive technology, and many new developments are trying to reduce cost to make more applications commercially feasible. Now, cost calculations are extremely difficult. The parameters vary greatly depending on the technology you're using, the material, the application you're printing, the industry you're working in, and of course also the requirements and the purpose of your parts. So today I just want to give you a basic principle and a basic overview of metal 3D printing cost and give you some rule of thumb to deal with. So let's start with a simple breakdown along the process chain. Let's assume you finished the design of your metal part. The first step to printing is to prepare the data for the printer. Now, the cost of data preparation is mostly driven by the engineer or technician who is performing it. The duration varies from a couple of hours for very mature data preparation software, for example for powder bed fusion, to more time-consuming programming steps for many of the especially high deposition rate technologies like powder laser deposition or wire arc deposition, which can take up to a whole day even. Now, once you finish preparing the data, the next step in the cost calculation is setting up the printer. Major cost components now are the operator and the printer. The printer cost itself is mostly characterized by an hourly rate, which includes depreciation, maintenance, consumables, floor space, and probably an overhead. And the most variable factor here is the depreciation. It is calculated by taking the total invest of the printer, including shipping, installation, and other necessary investments, and dividing this by the usual number of years, the usable number of years that your local tax law is allowing you for duration of the depreciation. In Germany, that's 5 years in many cases. Now, in order to arrive to an hourly rate of a depreciation, you need to divide this annual value into the number of productive hours of your printer. In many cases, the hourly rate of a metal 3D printers range between maybe 10 euro for a less complicated metal FDM system up to 100 euro per hour for more larger powder bed fusion systems, for example, or even more than that. Now, the next step of the process is the actual print. Here you have two major cost components, the material feedstock and the machine rate. For the material feedstock, you have to consider the printed part, but also some losses, especially while working with powder technologies. And material for the necessary supports you have to look out for, and for offsets or material that needs to be machined afterwards, you need to print that as well. Now, the machine rate is multiplied by the number of hours the printer is running. Pretty simple. Unfortunately, this value of machine run time is sometimes very, very hard to determine before an actual print. There are several estimations that have to be included, such as recoating time, deposition rates, cooling time, and packing density. There are three basic principles when calculating the production time of a printer, and they vary depending on the type of printer you're using. There are printers that are moving ahead along the base plate and printing the part step by step, and they're mostly only printing one part at a time, as you're used to in metal FDM or most of the HDR technologies. This print time is very much dependent on how long the head moves to print the part, and thus is very much dependent on the actual volume of the part. Now with powder bed fusion, it's a different story because you're printing probably multiple parts at once on a base plate, and you have a recoating process of the powder in between. But the recoating always takes the same amount of time, while the actual printing is depending on the volume you're printing. With ByNo Jetting, it's yet again a totally different story, because in ByNo Jetting you don't need supports, and thus you can stack parts on top of each other. And the binder jetter, the print head, is actually printing, it's not dependent, the printing is not dependent on the volume you're printing. So the print time for ByNo Jetting process is always the same time, and the costs very much depend then on how many parts you can actually put into one print job. The more volume you can put into the print job, the lower the cost. Now, those are the basics of the printing itself, but what happens afterwards? After printing, the post-processing steps begin, and they differ a lot between the different technologies. For powder bed fusion, parts usually have to be depowdered first, which is followed by a heat treatment to relieve process-induced stresses, and afterwards parts can be removed from the platform and reports can be removed. Now, depowdering and support removal are still mostly labor-intensive processes and manual processes, and the costs are driven by the hours that technician needs to go through them. Heat treatment, on the other hand, is quite a low-cost step, and it mostly depends on what kind of oven you use and how many parts you can move into the oven at the same time. Usually, though, the furnaces are quite low cost, and the costs don't have such a high impact on the total cost of part. For high deposition rate technologies, heat treatment can be an option, but it depends on the geometry. Some parts are simply too large to fit into a furnace, and in many times the parts are not even removed from the build plate, but the build plate is actually a part of the printed part. But almost in every case, HDR parts have to be machined from all sides around after printing, because you're just printing a raw part in the end, and those costs largely depend on what kind of part you're actually printing. ByNo Jetting parts have to be depowdered as well, which again is a very manual process, especially because removing powder from ByNo Jetting parts can be more tricky since the powder is much more dense together. After depowdering, the parts have to go through a sintering process where the furnace and consumables such as gas or electricity have to be considered. Now to the actual question, how much does metal printing cost? We developed a cost calculator which is very easily accessible via this website, and here you can type in the volume of your part, the dimensions of your part, the number of parts you want to print, and the group of alloys. The calculator then gives you a range of the cost, a min and a max value. That's the range of the cost where it might be for printing it in-house. Now, if you want to get a ballpark number and don't just want to go into a calculator and don't have a specific part, and you just want a ballpark number of typical production costs for metal 3D printing parts, then you can use average values for different technologies and materials based on the cost per volume. If we neglect machining and any quality management related costs, I can give you an example. For stainless steel, the cost to print a raw part vary between 0.3 and 2 euros per cubic centimeters, depending on the technology. Laser powder bed fusion and metal FDM are more expensive, while ByNo Jetting and high deposition rate technologies have result in lower cost. But be aware that those costs only stand for printing a raw part. All the machining is up to you, and all the other costs that, especially with regards to quality management, you have to still deal with. I hope you enjoyed this overview. Don't forget to subscribe and check out our online calculator. Thanks for watching. Until next time.